Hey Chris, my understanding was that I sent you an email wanting to talk to you about my project, and you said sum it in a few sentences, but I thought I'd just make a quick video explaining it because it's kind of hard to explain. So what happened is I remember the day in class that you were talking about how, people can be learning, would you rather be here or here? But what if your trajectory here was like this and your trajectory here was like this? And I seen that, like, what you were trying to do is you were trying to instill, like, a hope in people that they can still go forward. And part of our project is you give weight to social good. And here's what happened is right for the midterm, I had a speech in another state. I got real busy. I was underneath a lot of stress. And I basically went face planted the midterm. But I'm not worried about it because I know I understand the material. And I know that it's just 20% and I'll do fine on the final. But what it did is it put me in a subsection of students that I'm usually not in. And so I started to hear their worries and their concerns, and I started giving them this elevator speech. I said, let's think about it like probability, right? So here's how it works. So we did 6 P sets, right? And these 6 P sets can all be thought of as distributions. Now granted, they are not actual normal distributions, because they're probably going to be like this. You know what I mean? They're not going to, or they might be like this. They won't be normally distributed because I know that, the mu is not, the average would have to equal, the mean would have to equal the median for that to be true. But what I explained to them is we can think of this as 6 dependent events. And the reason I say that they're dependent is because your score on P-Set 3 would not be the same if you had not done P-Set 1 first. Okay? But we can still convolute these, we just need to figure in for the covariance. And so when we all convolute it, this would be at 0.45, right? And so we're going to call this, the convolution H. So then, another thing I said is, so then you have a midterm. Well, so let's say your midterm distribution was like this. And then let's say you were like me, you did real bad. So, you came in at like this part on the curve, right? Well, but this is only going to have a ranking of 0.2, right? And then I try to explain to them that, there's the 5% for attending, that's another convolution. But then there's going to be one more, we'll call this convolution O, right? But then there's going to be one more, this is going to be the final, and it's going to be weighted at 0.30. Right? I'm going to call this convolution P. And I tried to explain to people that you can figure out what you would need to get on the final to have a good chance based upon a prior belief. What would be my prior belief? Well, I know a smart math teacher or computer science teacher once told me that, a good sample size is usually about 200. Well, fortunately for us, there's this thing called CARTA. And if you look up grade distributions on Carta for CS 109, you get 1,430 students. That's a pretty good sample size. So I figured it out, and I could show the math, but it'd be more work, that if I hit the median on the final, or the mean, I could still come out with a B+, despite the fact that I straight face planted the midterm. Assuming that I perform on P-Set 4, 5, and 6, the same as I performed on P-Set 1, 2, and 3. But but this gives me even more chance to improve my grade if I can beat the medians on these 3. So now, thankfully, GradeScope has given me standard deviations, median, and all that stuff for all those P-Sets. So now, what I try to explain to people is, if I hit a 70th percentile, right, I can get an A- in the class based off of CARTA. And while your thing up here of learning helps, students worry about their grades. And so let's say the last 5% for, going to section and stuff like that is also distribution. We'll call that distribution E. And so what I like to tell people is now we can take all 4 of these distributions, which is going to be like this. They'll have their different weights, so we got to multiply them. This will be P, and this will be multiplied to the 0.30. This will be multiplied to 0.50. This will be multiplied to the 0.2. And then this one was at 0.45. And here's what we give students. All that sums together to give them hope. Because when I'm making this elevator speech to people, I can see their eyes light up as I started explaining what just hitting the median on the final can do for them, or what hitting the 70th percentile on the final can do for them. And I know the numbers ain't right, and that's why I need to talk to you, but if you want to weight it towards social good, we need more computer science majors. And we need to, like you said, you don't want students to have an unhealthy amount of stress. And while this is nice, and it's nice to explain it to them, I see their eyes light up when I give them H plus O plus P plus E distributions. So that's my idea. Let me know what you think. The reason I need to talk to you is because I know some of the distributions, like on the midterm, are really like this. You know, so it's like, you know, this half is different than that half, it's not symmetric. But I think just a back of the notebook kind of thing, you know, I can show them that even when you don't have the best data, you can make great approximations and get a good prediction of what you can do off future performance. So let me know what you think.